In this example, we have bivariate data, and the data is coded using changes of variable. T gets replaced by X, and G gets logged and replaced with Y. The regression line of Y on X is found to be this. Part A, Mika says that the constant minus 0.2215 in the regression line means that the colony is shrinking when the temperature is 0 degrees C. We need to explain why Mika is wrong. Let's think about where that minus 0.2215 has come from. When the temperature is 0 degrees C, so when T is 0, that means X is 0. If we sub this into the regression line, we get a Y value of minus 0.2215. However, this is not the growth rate. So Mika thinks this is the growth rate, G, but it isn't. This is Y. So we need to reverse the coding to find G when Y is minus 0.2215. So we go back to here. Look, how was it coded? Y was log G, so that means G must be 10 to the power Y. And since our value of Y is minus 0.2215, then G is 0.600 to 3 significant figures. So to answer the question and explain why Mika is wrong, well, we're given evidence that when T is nothing, the growth rate is 0.600, which is positive. So that shows that the colony is not shrinking, it's actually growing, and that's evidence why Mika is wrong. In part B, given that the data can be modelled by an equation of this form, where k and b are constants, find the values of k and b. So I'm going to derive the regression line and then compare numbers to see what k and b would be. I'm also going to show you an alternative method after I've done this. So logging both sides, make sure you don't fall into the trap of thinking that the right hand side, thinking that we can write that as t log of kb. We cannot, so don't do that. We can, however, use the addition law of logs, so that right hand side is log k plus log of b to the power t, and then we can use the index law. Log of b to the power t does become t log b. Now we're going to compare that with the regression line found earlier, or given to us in the question. If we just remember what was coded, so log g became y, and t was a straight swap with x. So now comparing everything else, so these two terms are both constant, they must be the same, and also log b must also be the same as 0.0792. By rearranging those, we get k is 10 to the power minus 0.2215, 0.600. It's actually what we found in part A. It's the initial growth rate. And that makes sense because if we go back to this and let t equal 0, so when t is 0, g is equal to k. So that makes sense that k turns out to be the initial growth rate we found in part A. We found k, we also need to find b, so solving this for b is 10 to the power 0.0792, so b is 1.203 significant figures. We haven't been asked to give interpretations of either of them, we've just been asked to find the values. Now very quickly, here's an alternative way of doing part B. You could start with the regression equation, the one we were given in the question, and substitute x is t and y is log g, and here's what you'd get. So I've replaced y with log g, and I've replaced x with t, and then really I'm working in the opposite direction to the previous method I used. So this time I'm going to start by raising both sides of the equation as powers of 10. So that's my first step, raise both sides of the equation as powers of 10. And then use the laws of indices. On the right hand side I have 10 to the power something plus something. You can think of it as 10 to the power n plus m, which we can write as 10 to the power n multiplied by 10 to the power m. And that's what I've done to get onto my next line. So 10 to the power first thing multiplied by 10 to the power second thing. And then another law of indices to get from here to here. So if you have 10 to the power m all to the power n, we can write that as 10 to the power m multiplied by n, and that's just what I've used to write it like that. I wrote it like that so we can see that this 10 to the power 0.0792, which turns into 1.20, that is our b. So 1.20, just by comparing this with the model we were given in the question, we can see that b must be 1.20. And also, again, by comparing this with the model, we can see k must be 0.600.